Anything which is not related to our common day experiences appears bizarre, just like the giant fish flying in your kitchen. Yeah, this is one of those. If rice grain are thrown at a sheet with 2 holes in it, a pattern soon begins to emerge. At any location, we discover the relation that number of grains arriving when both holes are opened is equal to the number of grain through hole 1 alone plus the number of grain through hole 2 alone. That's how the probability distribution look like when plotted horizontally. The probabilities add. We do the same experiment with water waves, and this time we measure the energy delivered by the waves per second. We get the intensity pattern I1 when only hole 1 is opened and I2 when only hole 2 is opened. But when both the holes are opened together, what do we get? We get an interference pattern.
Wow!
The height of water when both holes are open is equal to height of water when hole 1 is open plus the height of water when hole 2 is open. There are places where waves exactly overlap and create a larger height, but there are places where heights cancel and we get nothing. As I is proportional to height square, therefore it is clear that I12 is not equal to I1 plus I2. Let's take the case of electrons. We have filament as the source and holes are made in tungsten plate. At home, you can try it with photons from a laser source. Cut out a gap in a piece of paper and divide it into 2 parts using a hair. If you are running out of hair, this guy might help you out. The thing with electrons, photons or any other particle is that they arrive in absolute lumps. When an electron hits your face, you will feel it at a spot. Ping! And not smeared all over your face. Just like the splash of water. Like when the electrons hits the old TV sets, 1 pixel receives all the charge, momentum and energy of the electrons. Ping, 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 ping.
Bim 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 bum bim bum.
So when we measure the probability of arrival of electrons, when only hole 1 is open, we get P1, and when only hole 2 is open, we get P2. But when both holes are opened, what do we get? We get the probability pattern which looks like this. And just like the electrons, we get the same result in case of photons. Well, the mathematics is simple. We change the intensity with probability and we have to change h with something. We call it a probability amplitude. We add the probability amplitude to arrive from hole 1 and to arrive from hole 2 to get the total probability amplitude to arrive and square it to get the total probability. We got to use the same mathematics as we have to get the same curve out. But why are we getting this pattern? For instance, these empty location. When only hole 1 was open, we were getting some number of arrival of lumps. When only hole 2 was open, we were still getting some number. But when both holes are open, we are getting nothing. To summarize, electrons arrives in lumps, but the probability of arrival of the lumps is distributed like the distribution of intensity of a wave. To investigate further, we put the light source to detect which hole the electron goes through. We observe flashes either at hole 1 or hole 2, never both. In other words, it is true that when we look, the electron do pass through hole 1 or the other. The pattern emerging by the electrons through hole 1 is just like the pattern which we were getting when only hole 1 was open. The pattern emerging by the electron through hole 2 is just like the pattern we were getting when only hole 2 was open. Their combined distribution has to look like the sum, and indeed it does. What? When we look at the electrons, the distribution of them on the screen is different than when we don't look. Well, looking at the electrons disturbs things. Light make big impacts with the electrons. It's like getting deflected when hit by a giant ball. If we turn down the brightness and use less and less photons, some electrons sneak through unseen, and these unseen electrons, which we didn't see, form an interference pattern on the screen. In case of strong lights, there are not many unseen electrons, and hence we get the pattern which is represented by the sum. To summarize, if you have an apparatus to determine which hole the electron is going to go through, it either goes through hole 1 or the other. But when you don't look, you don't say that it passes through one hole or the other, because if you say so and start deducing from it, you will get an error. As our curves represented probability all along, this time we will propose that there will be probability all the way down to the fundamental laws. Example, there is no way to predict ahead of time which hole the electron goes. Some people will say that you cannot talk which hole the electron is going to go because it has to do with some complicated thing at the source. And if we knew all the hidden variables at the source and the complete physics, we would be able to predict which hole it is going to go. Richard Feynman in one of his lectures argues that, so if it was possible for you to determine which hole the electron is going to go when I have the lights on, then whatever gear you used back here to observe it when the light was on, you could have observed it even with the light off. And therefore you could have told me with the light off which hole it is going to go through. But then if you could do that, the curve would have to be represented by the sum, and that it ain't. Therefore it is impossible to have any information ahead of time which hole it is going to go through when the lights are out or when the lights is on. So it is not the act of unknown guess, it is the act of internal complication that makes the nature have probability in it. It seems to be in some sense intrinsic. Someone once said, the nature itself don't know its own future. To finally sum it up, this experiment suggests that one should not really blindly rely on the historic two-fold logic system of reasoning. We can't be certain that either our statement passes through the hole of truth or through the hole of falsehood. Reality can also be in the third state, truth. Neither true nor false until we measure. Wait, what? Whatever I have said and reasoned carefully might also be in the state of truth.